Welcome back to the breadboard. If you've been following along with these video series for the IoT 2020, or if you're watching it because you have an IoT 2040 even, you will now have your file system expanded and running with the full capacity of the SD card available to you. But there are still a couple of minor configuration items that need to be done in order for you to get up and running and be able to load things. The first one is you need to be able to provide a repository of installable modules when you use the OPKT package manager, and there isn't one configured by default on the IoT 2020 or the 2040. So what we need to do is add that, and this is a very simple process. I'm using WinSCP. I've SSH'd into it, and I'm browsing right now. It's showing me the home folder. If I go to root, go into etc and opkg, you will see two files. One is the opkg configuration and one is arch.conf. The configuration you don't need to touch. It's already set up quite happily and will work the way you want it to. The arch, on the other hand, in its default configuration, does not include the entries we need at the moment. A later release of the firmware will have this corrected for the devices we have. We need to make an additional 3 entries in here. So if you've got an early release of the firmware, by the time you actually get a hold of your product, this may actually be fixed. I'm using release 2.1 of the firmware from Siemens. If you have a later one, hopefully this has already been fixed, but if it hasn't, it's a very simple thing to fix it. So underneath item 11 here, you just need to paste in 3 entries. You need to add arch i586 space 12, arch quark space 13, and arch x86 space 14. Just save that, and that's all you need to add there. Now we still do not have any repositories, so what we need to do is add a file in this repository, and we're going to call it IOTDK.conf. So in my case, because I'm using WinSCP, I'm just going to go new file. You can use command lines if you're doing it that way if you like. Type in IOTDK.conf. You can actually change the name. It'll pick up all the files and work through them that you have in here. Press OK. This gives us an edit screen, and what we're going to do is paste in a number of source entries to suit the architecture. Now, because the IoT 2020 and the 2040 are based on the exact same processor as is used for the Intel Galileo, we can use the Intel's repository for these extra utilities. So that's the entries I'm going to put in here. I'm just going to add them now. Again, I will put these individual entries into the text of the post so that you can just copy and paste them if you like. So we have 4 of them. One is for, these are all for version 2.0 of the repository. And again, we just save that and exit, and that's all we have to do. Now in the PuTTY session now, in our SSH at the command line, we just need to do opkg space update, and it should now reread those files and bring in the package manager files, effectively the index or whatever you want to call it, so that we can now do some installations. So it's reading these various files. If you type the command opkg space update and it effectively does nothing, then for some reason you haven't edited the files correctly. So go back and have a look and retry. So we've just done this, and you can see that it's updated the source for all of these. So now that we've got the repositories updated, we're going to run the npm install-g unsafe perm space node-red, and this will install node-red for us. Now this is going to take a little bit of time, so I'm just going to stop the video and come back when it's all done and dusted. Okay, so we've got a few errors, but it looks like they're all to do with pre-built binaries not being available, and it has to default back to build mode, which is why one of the reasons why it takes a little longer to complete a few things with existing stuff. So nothing, outside of that seems to be in error. So I think we're fairly good there. Now we need to create a folder from our home directory for Node-RED and start installing some of the Node-RED modules. So we want to create a folder using a mkdir. Go into the folder, because when you install Node-RED modules, you want to be in the Node-RED folder that you create in your root directory. Well, I'm going to just paste in a little bit of a script here. It's basically a few npm commands that will install a few things. So it's going to install the dashboard and the Modbus modules to start with. So we're doing dashboard. This gives us the web UI, and the Modbus one allows us to do third-party communications to other industrial control devices that use the Modbus protocol. Okay, so those two have installed, no errors, which is excellent. So on to the next. So what we're going to do next is install some actual Intel Galileo drivers. So npm install Galileo IO. This will allow us to do some things that are directly applicable for the Intel X1000 soft processor. So what we're doing here is installing the Galileo, and as you can see here, it's installing some additional pieces and asking you to be patient because it does take a little while. Okay, that's all of those installed with nothing but a few warnings because the binaries did not exist, or because there's a few basic configuration items that are not important for the installation of the Node-RED modules, but they all installed there without an issue. So we should be able to see the fact that they are now over here. If I go into Node-RED and modules and just hit refresh, we should see the additional ones are all there. So that's excellent. So we'll continue in just a moment. Okay, that's all of those installed. I was a little concerned for some reason that the Node-RED didn't install properly, so I did a reinstall of it, just ran the exact same command, and this time it seemed to go in without an issue. So maybe it just had a minor hiccup trying to access the repository or something. Anyway, as you can see here, it installed quite well and hasn't produced any errors. So let's move on and we'll give it a go. So for Node-RED, if everything is working correctly, we should be able to just type Node-RED, and it should actually start up with default conditions. So let's just see if that works. Well, that's encouraging. So this is the first time Node-RED is starting up on here, so it may be doing a little bit of extra background tasks and things to get things going. And we'll also set it up so that it will start automatically. But so far it's encouraging. So we've got Node-RED starting. It's identified the system. It's got Node-RED running on 127.0.0.1. It will also be running on the default external IP address. It's running on 127.0.0.1, which is what it said down here, but it should also be running on 178. So let's just bring up a browser session, and we'll go 192.168.1.178 and Node-RED :1880. Node-RED should show up, and there we go. Now if everything has worked properly, there's MQTT installed. We did install that as a Node-RED node, even though we haven't got an MQTT server running locally. It means that it is now able to talk to Node-RED. Just scrolling down, there's the SQLITE for talking to a SQL node. Here is the ESP logon. So if you're using ESP8266s with Pete Scargill's version of the code, you can use this to configure those ESP8266s for the current date and time and things like that. Here is our Modbus nodes ready to use, and here are the dashboard nodes, which will allow us to create a rudimentary dashboard. And then we have the open weather nodes down here as well. So it looks like everything has gone in without an issue, which is excellent. If you wanted to test that that the web pages are working, you can simply just drag a few buttons on here, and you really don't even have to do much. Just go in and create a new UI group. Just take the defaults if you like for each one, and the tab. Just say OK, OK, done. Go to the switch, just say done, and it will take the defaults and anything else you might do. Let's put a gauge on there as well. We won't have to, you won't do anything, but it will certainly let us see that things are running. So if we say deploy now, that's now deployed, and up in the URL, if you do 1880/UI, it should show you those nodes. As I said, they won't be doing anything, but they will all show up. So there we go. There's the button that we created. There's the switch we created. There's the numeric control that we created, and there's the gauge. As I said, they're not doing anything, but they're working. So that basically has shown you that Node-RED is all working nicely. It's installed nicely, and we're ready to go with that. So the part that's remaining to do is to install the MQTT server. So let's just go and do that. So and also of course to get Node-RED and MQTT automatically starting. So for Mosquitto, we need to go to the home directory. We need to download the Mosquitto source files, expand them because they come as a tar, and then we need to go into the Mosquitto directory to allow us to start compiling. So I'm just going to break out of Node-RED there, and these are the commands you're going to need. I've just put them in default. I will, as I said, post all of this in the description to help you. So what we've done is we've got the Mosquitto source code, we've expanded it, and we've moved into the Mosquitto directory. So now what we want to do is we want to make it, we want to add a Mosquitto user, and we want to then start doing some additional work. So let's just add the user first. So that's simply add user Mosquitto, etc. Sorry, I just did the wrong thing there. I want to just do add user. I'd already copied some additional things. Copy that. Add user Mosquitto. But it may be telling me that it's already there now, of course. So we want to add a password. So use the same as the name. So MOSQUITTO, and repeat it. MOSQUITTO. The default for Mosquitto is to use Mosquitto for the username and Mosquitto for the password. You can change this, but right now I just want to use a default configuration. So now we want to make the Mosquitto. So we use a make with srv equals no, and let that run. This may take a few minutes to run, of course. Okay, so Mosquitto is now loaded, so what we have to do is set them to auto start. Now this is a little bit involved, but it's not complicated. So the first thing we want to do is to create the auto start node red.shell for Node-RED. So we want to put this in the /etc/init.d/auto-start_node_red.sh file, and this doesn't exist, so we'll have to create it. So the first thing, again, I prefer just to do this with WinSCP because it's nice and easy, is go to the root directory, go into the etc init.d location, so etc init.d, and in here we just simply need to right click, make a file, call it auto-start-node-red.sh. Now you can change this name if you like, but you will have to adjust the instructions that are later on. Just say OK, and in here we want to put in the instructions for starting Node-RED. So I'm just going to paste this in now. So what you've got is you've got the standard scripting starting to say that it's a bin sh file. A little bit of a comment. So the actual start command is user /usr/bin/node-red -u to specify the home directory as /home/root. Now if you want a different directory for that, then change it if you like, .node-red, and then -v for, and I'm just doing that so that we get verbose output to the default console. You can also redirect the output to a log file or something like that if you want to, and then the AND symbol at the end tells it to spin it off as a separate process so that you're not sitting there with a command prompt waiting to return when you exit node-red. This allows it to run as a background process. And then you just do an exit 0 to say everything worked okay. So you just save that, and that's done. Then the next thing we need to do is add some permissions to allow this to be executable, which is a simple command, chmod +x, which is the execute permission, and then give it the file name that we had, .sh. The H is wrapped around a little bit. So that's that done, and then we want to update rc.d, which is a command that allows you to add it to the daemons that execute things on startup. So we're just going to add that, which is update-rc.d, auto-start node-red.sh, and then default is the parameters we're giving it, or defaults. Press enter, it'll add the startup script to the startup menu, and we're done. Now we need to do the same thing for Mosquitto. So in this case we're going to call it auto-start mosquito.sh instead of obviously node-red. So the same directory, init.d, we will create another file, and this time we'll call it mosquito auto-start mosquito.sh. And in here we put almost the same, except of course it's going to be commanding Mosquitto to run, and we'll save that and set permissions on it, of course. I kind of put it in the wrong directory there, hold on. So it needs to be /etc/init.d. Okay, and we do the update rcd as well for the Mosquitto. And run that, and it's added it to the startup. Now the one thing I just realized I haven't done yet for Mosquitto, we've done the compilation and everything else, but we haven't finished making it. So we've done the make, but we need to go into the test broker and make that, and then we need to copy the files out to the various folders. So things like Mosquitto pub, Mosquitto sub, the Mosquitto itself, and the library for Mosquitto all need to be copied to various directories. So that's what I'm just going to do right now. You'd normally do that sooner, but it doesn't really make any difference, particularly on the order. Again, all these instructions I will include in the description so that you will follow them in the correct order. Okay, that's all done. So let's just do a reboot and see if everything starts up without an issue. I'll just pause the recording while the rebooting is taking place and resume once it gets back to the command prompt. Okay, so we're back up and running. What I've just done here is I've added a node-red read node in here just to test that the node-red module is working. And what I've done is I've configured it to read a holding register starting at address 1, quantity 4. It's just a random register. And I've pointed it to my Fleur industrial thermal imager, and so we will just test, because this fully supports Modbus, we'll just test whether we get a response from it. And as you can see on the right hand side here, it is indeed getting a response from register 0 through 7. It's asking for a holding register, which is actually 2 bytes, and it's asking for 4 of them, which would be 16 bytes. So here we are getting the values back. because it knows it's a holding register, it's actually already adding them together. So it's this is the whole register set, so 7000, and that just tells us that it's actually reading correctly. Now we're not trying to interpret the data, we're not trying to make any sense of it, we're just verifying that it's actually working. So that part is done. Now we need to have a quick look to see if the MQTT server is working. Now the way to do that is to use MQTT Lens or something else to connect to the MQTT server to start with, which we'll do now. So here is MQTT Lens. Let me just get rid of the current connection. We'll add one for this server. So we'll call it IOT2000 on port 178. And we'll give it an IP address, so 192.168.1.178. We have not configured a username or password to access the MQTT for the access part of it. It's running under Mosquitto as a username, but it's not configured for a username and password to actually publish and subscribe. So we should be able to create connection and actually get a green connection, which we have, and it now says it's connected. So given that, we should be able to now create a, let's just create a subscription. We'll give it the wildcard, so just a simple hash. We'll just say we want to see everything, and in the publication, let's just say test, and we'll give it a message of hello. Now I know this is all within MQTT Lens, but we've told it to connect to the 178 MQTT server, which is running on our IOT2020. If this does not work, then obviously we won't get a respond, but we do. There's our subscription, and we got the hello. Now that tells us that MQTT Lens is reading and writing, but what about Node-RED? So let's go to a Mosquitto MQTT reader, and we will set up a, let's just stop that one, and we'll set up a debug session to write out whatever comes in. We'll add a broker, so 178, which is our locally configured MQTT server. We leave this blank for automatic generation. There is no username or password, and we'll just leave everything else alone, so we'll just add that. Now for a topic, again we will just say hash, because we want anything and everything, and we'll just call this catch everything. And that should, when I deploy it, start showing us the MQTT when I publish something from MQTT Lens. It should show up in there as well. So let's just publish this, and there we go. You can see now that MQTT receiver over here under Node-RED is indeed receiving our message. If I change this to say goodbye and publish that, you will see that that comes through into Node-RED as well. So now we've got two things working here. We've got a Modbus calling out to, so it's acting as master, calling out to a FLIR thermal imager and reading data from one of its registers, and we have a MQTT server reading publication. So there's the Modbus and there's the MQTT server. So that is enough now to be able to start running this as a data concentrator and as an IoT gateway. Now, of course, you can configure the Modbus instance to also use, instead of TCP IP, you can configure the node to be serial as well by just changing this to serial, and it will obviously communicate with that as well. Now, one of the things with this particular Modbus module is that it has a limited buffer size. I found that if I increased it beyond about 4 or 8 bytes of received data, it would give me some buffer overflows. That's probably just trying to optimize itself for smaller systems. There are other modules available from the Node-RED system, like the repository, that handles much bigger buffers, and I've used these on other systems. Just this one here that I loaded actually will handle serial or TCP/IP Modbus all within the same Node-RED modules. If you want to have the bigger buffers and things, then short of modifying the source code and then just simply recompiling it, which is perfectly doable because it's all there, it would be easier just to load a separate TCP/IP Modbus and a separate serial Modbus. For now, though, this will do what we want for future testing, and I will probably show you how to use the other one as well, because I do already have quite an extensive test that is communicating with the FLIR thermal imager and displaying not just the image from the camera, but also all of the analog readings for temperature, high, low, average, etc., etc. We will do that in a separate video. For now, in this one, what I wanted to show you was a little bit of configuring Node-RED, getting the repositories up and running, configuring Mosquitto, and also using the SQLITE, which we haven't shown you yet. So let me just get that bit done, and we'll show you that that is also working. So in order to test the SQLITE, the first thing I'm going to do is create a database and run a script that will create tables within the database and set permissions, etc. on that. So I'm just going to run this now. I'll provide the whole script, of course, in the description. So what we did there was in the home directory, if we go back to WinSCP and tell it to just refresh and go into that again, because I rebooted it, just needed the refresh. We should see in the root directory a database now directory, DBS, and in there we should see the data table we just created. And there it is. Now it's partially text readable, but not totally. And to be able to test that, we should be able to use Node-RED with the SQL connection, SQLITE tool, to be able to actually read from it. So let's just try a couple of things and make sure that that works as well. So the first thing we need to do is drag a SQLITE node onto the screen, and then we've just added a debug at the end of it. We'll add a trigger in a second as well. Within the SQLITE node, we need to tell it its database, which in this case is home/root/dbs/iot.db, which is basically what was created from the script I ran. We just click add. We'll just call that db, just for the sake of giving it something. And we're just going to add an inject trigger, which we're just going to leave to be pressing a button to test this. And in here we're going to have a string which will be simply something like select star from, and we need to pick a table. So one of the tables that was created was pins, and that actually had some data injected into it as well. So let's just say pins, P-I-N-S. And I think that should be enough to actually get a response from the SQL server, if I remember how to configure this correctly. So let's just try that and deploy it. Let's just clear the... Okay, so we've created the SQL node. We have a simple command, select star from pins, which was created when we ran the little script to create the tables in the home directory for the root user under DBS folder. We need to set the topic to be the select command. The payload really doesn't matter. And the DBS simply points to where the database is, which is home root dbs iot.db. We've deployed that, and when we click the button now, as you can see here, we get a response from the SQLITE database. We can also do that from the command line right here, where if I just exit this for a second, star from pins, And there's our table. They're all at zeros, but nevertheless they have data in them. If I just do .tables, it'll list all the tables that were created from that script, and there they are. So that's it, proven. We've got SQLITE running, we have Node-RED running, we have MQTT server running. These are all the basic ingredients you need for creating an IoT gateway that can talk to Modbus, as we've seen. It can talk to an MQTT database. If you don't want to run one locally, you can use one of the many cloud-based services for that. In a later video, I will show you how to configure this to talk to some ESP8266s running some software that allows it to use an MQTT server and provide temperature and humidity readings and everything else. This video is all about getting the resources set up, loading the applications to start doing some industrial processing and communicating with some industrial devices. And I've shown you talking to a FLIR thermal imager using Modbus, and that's what I wanted to show you basically. And I've shown you also that we can have a database in there that Node-RED can talk to that will allow us to create history data, etc., etc. So that's going to conclude the video because it's gone on quite a while, and I know because of the nature of this specific video it is a little longer than I'm trying to do, but there's a lot of detail in here, and you really do need to be careful when you install all this stuff. I think eventually Siemens is going to have all of these repositories and the binaries set up, either included in the image or at least easily available through the package manager, so that you can load them without having to compile from the source code every time, which would make the process a lot quicker. For now though, I've shown you how to get it in there and up and running, so I will finish the video here. I hope you liked it, and I hope you'll recommend it to your friends, and I will see you next time. Bye.